Right, in this video, we're going to talk about finding confidence intervals for proportion. A lot of this is going to be very similar to what we had last time when we talked about confidence intervals. Right, so pay attention, see what is different, and we'll see what's changed as well. All right, so Chief-Ru knows how the central limit theorem for proportions, or P, works. We did that in a previous section. So she takes a sample, she lets X be the number in the sample that are yeses to some particular property, and then N minus X is going to be the number of no's. So really the only thing she needs is the number of X's in the sample size. She takes her sample size large enough for the central limit theorem to apply, right? And remember, that was at least 10 in each category, 10 yeses, 10 no's. So she calculates her sample mean, right? Our P hat is X over N, the proportion of yeses in the total sample. And in this time, she wants to use that to estimate the population mean using this confidence interval. Okay, so if we only have our sample mean, our P hat, right, we can't expect it to be exactly the population mean, the thing we're after, our P. So what do? We calculate a margin of error, we're going to call it M, and we look on either side of P hat and say that, within some level of confidence, our population proportion is going to be P hat minus our margin of error and P hat plus our margin of error. Right, and as last time, the margin of error is going to depend on a couple things. Right? It's how confident we are that P is in our interval, right? And our Z alpha over 2, right? This critical level in terms of the Z's is going to, again, carry this confidence level. And the other thing it's going to depend on is something we're going to call the standard error, right? Last time we had our sigma over the square root of n. That was really our standard error, and this time our standard error is it's going to be something that's going to depend on our sample size. So our sample size is going to affect our margin of error again. Right, so how do we calculate this? Right, our margin of error, M, is going to be our critical value, Z alpha over 2. Those are going to be the same exact Z's as we had last time, times our standard error, right? So when we looked at the proportion distribution last time, we have seen this calculation, the square root of P times 1 minus P over N. But this time we don't actually know what P is. We only know our sample P hats, so we use that instead. Right, so again, running through our definitions, Z alpha over 2, that's our critical value. Depends on our confidence level, right? As the confidence level goes up, our critical value goes up, and our margin of error increases. That's going to make our confidence interval wider. The square root of P times 1 minus P over N is our standard error, and again, it uses our sample proportion because that's the thing we have access to. All right, so our confidence level, these are the exact same things as we had last time. 90%, we have our critical value of 1.645, 95% is 1.960, 98 is 2.326, 99 is 2.576. And if we need more values, right, we look on our standard normal table and try to find the proper Z value for half of our error on the one side. All right, so the confidence level is going to be our probability as a percent that the sample mean, right, the thing that we calculated has a Z-score within plus or minus Z alpha over 2 of our true population mean. But again, we don't know our true population mean. So how do we do this? We do this by doing a confidence interval. All right, so just as last time, we have our confidence interval, P hat minus our margin of error, up to P hat plus our margin of error. This is going to be our confidence interval. And what we say is we are whatever percent confident, right? That's going to be our Z alpha over 2 is going to carry that confidence, that the true mean, which was P again, is going to be between P hat minus M and P hat plus M. And in reality, what we calculated is something where if we take sample sizes of size n, right, this same n over and over, whatever our confidence level percent of these confidence intervals will contain our true population mean in them, right? So if we say that we're 99% confident, if we take 100 of these samples, 99 of them will contain, or we can expect 99 of them to contain the true population mean. Okay, so let's look at some calculations based on knowing our sample